Hello students, let us begin with a very interesting topic today, factors that are affecting the enzymatic activity. This is from biomolecules chapter and this is part 9. It is also called as enzyme kinetics. There are different factors like concentration of enzyme, the concentration of the substrate, the temperature, pH of the medium, activators present in the reaction or inhibitors present. All these affect the rate of enzymatic activity, which we also called as enzymatic kinetics. First, let us see how enzyme concentration affects the activity of the enzyme. This is actually directly proportional. Increase in the number of the enzymes increases the rate of chemical reactions. Increases the rate of enzymatic reaction. More and more products will be formed. For example, if you see in this case, on x-axis we are plotting time and y-axis we are seeing how much enzymatic activity is occurring or how much product is formed. Initially, when there is no enzyme, literally no product is formed. When there is 1x time of enzyme, you can see the rate of enzymatic activity has increased. And if there is more enzymes present, the enzymatic activity increases to a higher rate. So it is directly proportional to the concentration of the substrate. More the enzymes present, more the substrate will be converted into product. Now, let us see how temperature affects the rate of enzymatic activity. We all know we store food in the refrigerator. We put all the perishable food items in the refrigerator because in the fridge there is lower temperature, less temperature. Why? Because in lower temperature, enzymatic activity is inactive. Whereas when we want to store milk, what do? We boil the milk and keep it. Why? Because boiling or heating denatures the enzymes, kills the enzymes present in it of the bacteria. Thus, the rate of reaction of an enzyme reaction changes at different temperature. Enzymatic reactions occurs best around 37 degrees centigrade, which is actually average body temperature of a warm-blooded animal or a homeotherm. But above 45 degrees, the enzymes will get denatured. For example, in this graph, you can see on x-axis there is temperature, as you can see here, and y-axis there is rate of the reaction, enzymatic reaction. Lower the temperature, enzymatic activity is low, but as the temperature is increasing, the rate of enzymatic activity is also increasing, and as the temperature further increases above 40 degree, the enzyme starts denaturing. So at lower temperature, enzymes are inactive. At higher temperature, enzymes are denatured. They work very well at optimum temperature near about 20 to 40 degree. Now let us see how the substrate concentration affects the rate of enzyme activity. Initially, if you see this graph, on x-axis there is substrate concentration, y-axis there is enzymatic activity. Initially, when there is less substrate, the enzymatic activity is less. Then as you are increasing the concentration of the substrate, the enzymatic activity also increases. Further you increase the substrate concentration, a time comes when the substrate concentration, irrespective of it, the rate of the velocity at which enzyme works becomes constant. Even if you increase the substrate concentration beyond this, there will be no added effect, there will be no active sites present, and therefore at optimum concentration of the substrate, the enzymatic activity becomes normal. Now, if you consider this initial point as V0, which is also called as the initial velocity of the enzymatic activity, then this will be the Vmax. Vmax is the maximum velocity at which the enzymatic activity is maximum. So somewhere in between, here there is half of Vmax, and whatever substrate concentration needed to reach this half of Vmax, it is called as Michaelis maintain constant. Again, I'll teach you about it, but this is called as half of Vmax, and this is nothing but also termed as the rate of or the amount of substrate concentration which is required to reach half the Vmax enzymatic activity. It is called as Michaelis maintain constant. Let us see further. Again, I repeat, this is x-axis. Here you can see substrate concentration. This is y-axis. This is v0 initial velocity. Correct? This is vmax, the final velocity where the enzymatic activity is becoming like stagnant, we can say, or there is no change. And this is the half of vmax. and amount of substrate that is required to reach half Vmax, it is called as Michaelis Menten constant. It is defined as amount of substrate concentration, which is always counted in moles per liter, to produce what? Half the velocity of Vmax. Where is it produced? Here. How much is concentration of substrate is required? This much. This is termed as Michaelis Menten constant. It is a very important or a characteristic feature of a given enzyme. If the Km value is low, this means what? The affinity between the enzyme is substrate is very high. But if there is a high Km value, more time is needed, more Km values there, they show that there is weak affinity between the enzyme and the substrate. So this is inversely proportional. Low Km value, listen carefully students, lower the Km value, more strong affinity between whom? Enzyme and substrate. Correct? And higher the value of the Km, higher the value, lower is the affinity, less is the affinity between the enzyme and the substrate, and therefore it takes more time to reach Vmax and more times to reach half Vmax because there is less affinity between the enzyme and the substrate. Km values are in usually the range of 10 raised to minus 5 to 10 raised to minus 2 moles. So I hope you have understood what is Michaelis Menten constant and how it is inversely proportional to the affinity between enzyme and substrate. Let us now talk about what is the effect of pH on enzymatic activity. Different enzymes, they work at different pH. There are enzymes such as the enzymes that are secreted in our stomach by gastric glands. Hydrochloric acid is secreted, and so in the stomach enzymes like pepsin are secreted, which can work very well in acidic medium. So most of the enzymes, they are able to perform the activity more at lower pH, acidic pH. So then the graph will come somewhere like this, isn't it? But there are some enzymes which can work very well at alkaline medium. Example, the enzymes that work very well at alkaline medium are trypsin, chymotrypsin, which are secreted in the small intestine. So different enzymes are able to work at different pH. Pepsin works very well at acidic medium in the stomach, whereas trypsin works very well in alkaline medium, which is present in the small intestine. So different enzymes can perform the activity very well at different pH. If there is effect of other substances also, like coenzymes, if coenzymes like nicotinamide adenine dinucleotide or FMN, flavin mononucleotide, are present especially in the ETS system of the respiration, we know that the activity of the enzymes, it increases. If activities are present, like these activities are usually minerals, inorganic minerals like magnesium, zinc, manganese, iron, what happens? The rate of enzymatic activity increases. But if during the reaction, if there are some inhibitors, some competitive or non-competitive inhibitors, like few drugs or something, then what will happen to the enzymatic activity? It will reduce. So in this way, different factors we have studied which affects the enzymatic activities. In next video, we'll start with a new chapter, photosynthesis. Thank you.